we've done a lot with solving systems of equations that were all linear systems. It was all reviewed from last year, but I wanted to make sure you guys were really able to do it, because now we're going to look at two different things: linear quadratic systems and quadratic systems. So a linear quadratic system is when you have two equations and one of them is linear and one of them is quadratic. And all three of these examples have one linear, one quadratic. The first one, if you're to solve it graphically, graph y equals 4x plus 3, graph y equals 2x squared plus 8x plus 3, and what did you get as your solution?
X equal to 0, y, 0, 3, and -2, 5.
So the graph looked like this. And your points are 0, 3, -2, 5. So if you're going to write your answers, I would write them as ordered pairs. 0, 3, -2, -5. Because if you don't write them as ordered pairs, you don't know which x goes with which y. If you just said x is equal to 0 and -2, y is equal to 3 and -5, you don't know which ones go together, and it does make a difference. Like 0 and -5 is not a solution, even though they're an x and a y. They have to be together. So for all of these linear quadratic or quadratic systems, I'm going to write my answers as ordered pairs. So the next one was y equals x squared and y equals 2x minus 1. Is that this one? Yep, that looks like it. This one only had one solution at 1, 1. So x is equal to 1, y is equal to 1. And then the third one must be this one. No solution for that one. If you remember, when you're solving a linear system, you usually get one solution because there's two straight lines, they intersect at one point. But you could get no solution, or there's one other thing. Do you know what the one other thing is? Do you remember? You could get an infinite number of solutions if the two lines were actually the same, one on top of each other. But when you have a linear quadratic system, these are the three choices. You could either get two solutions, or one, or none. These are quadratic systems. I want you to take a couple of minutes and graphically find the solutions to those as well. So for the first one, A, here's the graph that you get. And this one also has two solutions. Just like a linear quadratic system can have two solutions, a quadratic system could have two solutions as well. So we have, oops, that's not what I wanted to write. We have solutions of -1, 3 and 2, 6. The second one what's this? Did it look like this? So what about that one in terms of solutions?
No solution.
No solution. No solution. And then the third one looked like this, and it had one solution, and the solution is 0 and 4. X is 0, y is 4. If we're considering quadratic systems, you could have two solutions, no solution, or one solution. Is there any other possibility? Infinite, right. You could also have an infinite number of solutions with a quadratic system. If the two quadratic equations were actually the same, or one was a multiple of the other, then you'd have an infinite number of solutions. That's one other possibility that I didn't put on here. We do also need to be able to solve these algebraically. And so looking at this, I'm going to solve this using elimination. And you guys already know how to do elimination, you just haven't done it with this type of a system. Elimination is really good for a quadratic system. It could work also for a linear quadratic system actually pretty well sometimes. You'll probably find you use elimination more often than substitution with these type of equations. But remember, with elimination, one thing that I want to do here is I want to line everything up. So I have the x's and the y's, the x's and the constants like all one underneath the other. But I also want to think about what variable should I eliminate here? Y. Yeah. Because if you eliminate the x squareds, then you still have x's and y's. If you eliminate the x's, you still have x squareds and y's. But if you eliminate the y's, then you're going to be left with x's and x squareds, which is just a quadratic equation that you should be able to solve. So I think if I multiply this first equation by -4, does that seem to make sense to you? Then we should be able to do that. So this will become 16 x squared plus 4y plus 8. And then it's going to be equals 20, but I'm going to say minus 20 equals 0. Just to move that over to the other side so it looks the same as the other one. And then the other one is going to stay like it was. 3x squared minus 4y minus 46x minus 37 equals 0. And then I can add those together. I get 20x squared. No, not 20. How many x squareds? 19 x squared. We eliminated the y's. Those are gone. That should have an x with it. So I have 8x minus 46x, which is negative 38x. And then negative 20 and negative 37, so negative 57. Now this is a quadratic equation, and you can solve a quadratic equation by factoring, and that looks like it could be really hard to factor unless it has a common factor. Does it have a common factor? 19. So if we factor out the 19, we'll get x squared minus 2x minus 3. Just dividing each of those by 19. And then factor, that becomes x minus 3, x plus 1. So it's a little harder than elimination just with a linear system, because with elimination with a linear system, we do this elimination and end up with a linear equation that's really easy to solve. But now you have to go through this process of solving a quadratic equation, which is a little bit harder. But we'll get here x equals 3 and x equals -1. Those are the two x values. So this is going to have two solutions. But we also need the two corresponding y values. So we go back to one of the equations that we started with and fill in those x values to find y. So I'm going to take the first one and I'm just going to change it to y equals -4x squared minus 2x plus 5. So moving the y over and moving the -5 over. And then I can fill in those x values. So I'm going to take this and do y equals 4 times 3 squared minus 2 times 3 plus 5 to get this y value. Just punching that in my calculator, or you can do it in your head. I get y equals 35. Oh, no, I don't. I forgot the negative. Did you see that? that should have had a negative in there, so let's try that again. Y equals negative 37. And then do the same thing again, but filling in negative 1. So it's negative 4 times negative 1 squared minus 2 times negative 1 plus 5. And we get y equals 3. So then when we write our answers as ordered pairs, because we need to keep the proper x and y together, x is 3, that was one of them, and the y value that goes with that is negative 37. So that's the part of the answer. And x is negative 1, y is 3. So just make sure when you're done solving that you do write your answers out as ordered pairs to make sure you have the proper x's and y's together. Here's the next one. This one we're going to solve by substitution. What kind of system is this? The last one was quadratic. Yeah, this one is we usually say linear quadratic. Quadratic, linear, doesn't really matter, but usually we say linear quadratic. So this is a linear quadratic system. We're going to solve by substitution. What variable then should we isolate in which equation? Isolate the y? You should isolate the y because the same as with elimination, you want to deal with the y's first, so you're left with something with x's and x squareds, because that you can solve. But if you're left with something with x's and y's, or x squareds and y's, you can't solve it. So we're pretty much always going to either eliminate or isolate the y. Almost always. I shouldn't say always, because there are some times when I would eliminate something else. But if we take the second equation and isolate the y, that should be fairly easy to do. This becomes y equals 2x minus 2, just adding 2x to both sides. And then we can substitute that into here for the y, so we get x squared minus 2x minus 2 minus 2x equals negative 2. And what we have here is a quadratic equation in just x, a quadratic equation in x, which means it has x's and x squareds, that we can solve. Expand and simplify, get everything on one side of the equation, and then factor. So that's what I'm going to do now. X squared minus 2x. Notice that that becomes a plus 2 because of the negative there. Negative times negative is a positive. And then minus 2x. And I'll do plus 2 equals 0. This becomes x squared minus 4x plus 4 equals 0. And that you know how to solve because it's like almost one of the very first things we did in this course, right? Factor it. X minus 2 and x minus 2. So this gives us only one solution, x equals 2, since both factors were the same. So we only have to find one y value. Y is equal to 2x minus 2. So 2 times 2 minus 2, which is equal to 2. There are a lot of 2's on that one slide. The ordered pair is 2, 2.